Hello everyone, in this video I will discuss the basics of multimedia processing by demonstrating how signal processing concepts are applied to both audio and media data using Python. Multimedia processing combines techniques from digital signal processing and image processing to analyze, enhance, and modify real-world media such as sound and images. First, I load an example audio file using the librosa library, which is commonly used for audio analysis. After loading the audio signal and its sampling rate, I plot the audio waveform. The plot shows how the amplitude of the audio signal changes over time, allowing us to visualize observed variation in loudness and structure. Next, I compute in short time Fourier transform or STFT of the audio signal. The STFT allow us to analyze how the frequency content of the audio changes over time. I convert the magnitude of the STFT into the decibel and display it as a spectrogram in this plot. Okay, in this plot, time is shown on the horizontal axis, frequency on the vertical axis, and color intensity represents signal energy. This visualization helps us understand which frequencies are dominant at different moments in the audio. After that, I apply a Butterworth low-pass filter to the audio signal. I define the function that designs the filter and applies it using the iFilter function. With a cutoff frequency of 1000 Hz, high frequency components are attenuated while lower frequency are preserved. I then plot a short segment of the original and filtered audio signal together. From this comparison, we can clearly see that the filtered signal is smoother, indicating the removal of high frequency content. Next, I move to image processing. Instead of loading an external image file, I create a grayscale test image using a random pixel values. I display this original image to serve as a reference. I then compute the two-dimensional fast Fourier transform of the image and shift the zero frequency component to the center. The magnitude spectrum is displayed, which reveals how different spatial frequencies are distributed in the image. Bright regions in this spectrum correspond to strong frequency components. After frequency analysis, I apply spatial filtering in the image. I use a Gaussian blur to implement a low-pass filter, which smooths the image by reducing high-frequency details such as edges and noise. By comparing the original and blurred images side by side, we can clearly observe the loss of fine detail caused by low-pass filtering. Finally, I demonstrate image denoising. I add artificial noise to the original image to simulate a noisy environment and then apply a median filter to remove the noise. The final set of images shows the original image, the noisy version, and the denoised result. The median filter effectively reduces noise while preserving edges between are better than simple averaging filters. Interpreting the outputs, this example shows how the same signal processing concepts, such as Fourier analysis and filtering, can be applied across different media types. In audio, these techniques help us analyze and enhance sound signals, while in images, they allow us to filter, smooth, and denoise visual data, highlighting the importance of multimedia processing in real world applications.